MacBook board. So we intend to fix this. It's a 2017 in place of 2015 that had a 40 PCH, because this would seem like a quicker option compared to waiting for um, components to arrive, and then yeah. So this board has obviously been attempted before. It's floxing around it, and it doesn't start. So basically, see, so connect our charger. We don't have a fan speed, and this is not because of a faulty fan, but just because obviously um, the board is not working as it should. So let's see if we have PPDC in. PPDC in is present. Let's see what we have on our PP bus, and let's go. And by the way, it's a 2017. The GTEC has been taken out, so we can use the same 80-00-165 board view from last time. So let's just leave that. Now let's see what we have on our PPDB42 that is present. Let's see what we have on our PP bus. PP bus is 8.8. Okay, that's about 8.6. That's fine. On the other side. Okay, now let's see what we have on our source rail. Let's see, source we can 3.3, that's fine, and out 3.3, that's fine. Now let's see, are we in SO state? Okay, so 50, that tells us that we are in SO state. The next thing we want to now find out is what SO rail is not being generated that is preventing the machine from actually starting. Now, the fact that we are in SO state, it simply means that most of the rails are going to be already present. So the next thing we want to now do is let's find out what rail is not present on the board, and that's why we're not having the machine fully working. So what we can clearly do, if we come to U1900, the clock section, let's not worry about that. That is past. U7501, let's not worry about that. We are in SO state. U7400, let's see what we have in 7400. Let's just basically open up the schematic, give you guys an idea of what U7400 is. So it's 820-00164. So the board is somewhat five, not four. The board is in SO state, but it's partially in SO state, I would say. So let's see what is U7400. U7400. Okay, U7400 is gonna be the RAM supply circuitry, which is the LPDDR3 supply circuitry. So let us see what we have on that rail. So let's see what we have on L7430. Let's see, that's the output of the rail of E7400. So let's see what we have on L7430 first. First thing first, let's see what we have on the L7430. Search for L7430, L7430. That's an inductor on the output line. Okay, which is going to be this one here, which is this. So let's see what we have there. Okay, so that is not present. Now, just like we said about real creation, now the next thing we want to do is we want to see, do we have a short on that line that is not present? Let's see. Let's see, do we have a short on that line? No, we don't have a short on the line. We don't have a short on the line. Let's leave that. The next thing we want to do is just like we said before. Now that we have confirmed that the output is not present, let's now see the inputs. Now let's see what we have in the inputs. So let's see what we have on the V5, the V in, which is going to be PBV5, and that's S5. So pin 12. Let's see what we have on pin 12. Let's see what we have on pin 12 of E7500. Okay, so pin 12 of E7500, that is going to be the power into the chip. Let's connect back our charger. Mm, so we can measure that at this cap here, C7500, which is oh okay, switch it to voltage mode. Yes, okay. Can you see that? Can you, is it, you see? Okay. Thank you, Peter. Okay, so we can measure that on the cap here. No, this one here. This is 700 here. So let's see what we have. We have 5 volt. Yes, we have 5 volt. Now we can just quickly go check if we have enable signal here, which is let's see if we have pin. Let's see what we have on pin 16. That's going to be the enable signal to the chip. I'm just going to go back to it. So where is our 16, which is here. So we want to see if we have so 17, 16 and 17. Let us see what we have on the 15, pin 16 and pin 17. Let's see what we have on those pins. So obviously, remember we talked about, let's see if there's an enable signal, which is basically like the on switch for the chip to say if it's told to turn on. So let's see what we have on pin 16 now. So we can measure that at C8111, and there is also a TP close to it. So this is a C8111, and we can use this TP here to confirm that. Let's see. Yes, we do have an enable signal for it. Now let's check. Let us then check again pin 17. Let's see what we have on pin 17. Okay, let's see what we have on pin 17. So we'll confirm that at R1970. Let's see, R1970 is going to be this resistor here. So let's see what we have. Let's see if our SO is present. Yes, SO is present. And then the other side, yes, so we have that is also present. So since we can confirm that, and let's just go back to it. We can confirm that 17 is present, 16 is present. Now, the next thing we want to do is uh, we can now again, let's just confirm that indeed we do not have a short on that line. So the first time we used continuity mode. This time we want to use diode mode to confirm that we don't have a short on the line. Let's go back to that inductor, which is this one here. Let's see what we have. So for diode, red probe has to go to ground, and then black probe 0.27. So let's get another board to see if let's see what we have there. Let's quickly check that message. Okay, okay. So so now let's see, because that seemed a little bit low. Let's just confirm on this board, black red probe to ground, and then black probe here. Let's see. Okay, that's 0277. Okay, okay, that's about it. Okay, that seems to be fine. Okay, just to be sure, let's get from another board. Which board is which machine is this one? Oh, this is, oh, okay, the one with excessive, no, no. Is it? Yeah, yeah, it's the one with excessive, okay. But how come there is no marking on the board? Okay, let's just confirm that indeed that's what it should be. Diode mode. That's a little high. 323, and this says it's 277. And this is also what? 278. Okay. Okay. That's really not. It's a bit of a. Okay. Let's see. So what we now want to do is, since we have the enable signal is present, the next thing we want to do is we want to first replace this chip. Let's first replace it 7500 and see if we have any changes. Okay. Let's just switch back to continental mode. Let's just quickly check to be sure we don't have a short. Everything showed we don't have a short on the pads. Sensitivity out, process it better. Oh, okay. Thousand. Making contact. What is that? Okay, that seems to be a short. What is that? What is that? Hmm. That's a short. 1.2 volt. Okay. And that is gonna come from, okay. Let's see something. Okay. Hmm. That will explain why P one is not being powered, because the 1.2 volt line is shorted. Okay. Hmm. Okay. Which is okay. No, it's not a data line, it's a power line. So it's supposed to have 1.2 volt in S3. Let's just check that again to be sure that indeed it's shorted. Yeah, we have a short there. Okay, so this one, let's go to pin 2 of the 7500. Pin 2 of the 7500 is gonna be 1, 2. Okay, so let's see where that rail is generated from. We copy that and then we paste it because we want to see where the rail is generated from. So this is not where it's been generated. This is where it's going into something. We need to see where it's being generated from. Go nest, 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 nest. Let's see. 1.2 SS. Okay, this is the SO, not the S3. We needed the S3, not SO. That's it going into something, and that is it coming out. 1.3 and E7500. Wait, what is that? That's the same rail. That's the same rail that's generated from L7430. Let's see what's happening. Let's just check this other side. It wasn't shorted before. Okay, let's check Q7430. Let's check Q7430, which is Q7430 is gonna be, yeah, this. Let's see what the story is there. Okay, 7430 is out. Let's see if we have a short test here. Okay, our short is gone. Okay, our short is gone. Now let's put back. Let's put back and okay, let's try a bit of soda and that. Okay, let's grab another A7430. Let's just confirm that our short is gone. Okay, our short seems to be gone. But sometimes that rail can be very funny. Let's put it back and see what we do with where we are afterwards. Okay, before we put back A7400, let's just confirm that we don't have a short. It's important because that rail can be very funny. Let's see if we don't have a short. Okay, we still don't have a short. Okay, now let's put back a 7500. What is it doing? Yeah, so um, okay, Okay, I'll be with you now. Just leave it in that shell. Um, so let's just confirm again. Let's see if we don't have a short there. Okay, this is the U700 we took out, yeah? This is the one we took out from here. And by the way, obviously, when you're replacing a chip like this one, you have to be aware of what is pin one. It has orientation, and usually pin one there will be a small, there will be an indication of what pin one is. Okay. Okay. Let's let's just be sure that we don't have a short on the line. Okay, that looks good. The next thing we want to do is you know, guys, I usually don't like to see my fans when I'm troubleshooting. I don't want to depend on my fan. I want to see what I have. So next thing is let's see if we have, just again confirm we don't have a short anywhere. Okay, now we can connect our chargers. Oh, by the way, I'm not worried about this because there's right now that doesn't really concern me, and the function of that to this board is very limited. It's just to get the battery to communicate with the board. Nothing. It doesn't really, and also to obviously charge the battery as well. So right now, that's not my concern. I'm not really worried about what's going on there. First, I want to get my board up and running before I can worry about the connector. Okay, so let's connect our charger. As like so now, what I want to do is let's see at least let's see if we progressed or we retrogressed. I mean, we were in SS state, but then we had a missing RAM rail. Right now, let's see if we still even in SS state or we are way behind. So let's see what we have. Okay, PP bus is still 8.6, 8.5. That's pretty much fine. Let's check if we have if we are in SS state and the inductor here, which is gonna be L7520. Let's see if we are in SS state. Okay, that's pretty much still fine. We're still pretty much in SS state. Now let's see. This was the rail that we didn't have, which is gonna be one point. For yeah, we did it on about around about 1.2. Let's see if that is present now. Yes, that is present now. So and then let's see if we have what you have here. That's fine. And the CPU line, that's fine. So most likely we should have a fine spin now, but we still can't confirm. Let's see. Let's see if our fan is spinning now. Okay, we have a fan spin. That's good. The next thing we want to see now is the fan going to continue or it's going to stop? That's a problem. That's what I don't want to see. Okay, fine. That's fine. That's fine. That's fine. So two things here. That's not good. That's not good. Okay, let's just try again. Let's try it again. Let's see. That's not good for the fan to stop because that obviously would mean that it's not posted. Nah, that's not good. Okay, so a couple of reasons why that is going to be the case. Um, I okay, so let's just see if mm, mm. Okay, we'll step closer, but I don't like this date. This is not such a this is such an open-ended type of situation that the board is in, whereby there's too many things that could cause it to behave the way it's behaving. Uh, um, okay, so uh, okay, first and first, let's tackle. Okay, let's just confirm that we have other rows present, and then see what you have here. Okay, fine. It's fine. That's fine. That's fine. That's fine. Okay. Okay, so we want to start from the SMC. That's where we want to start from. So, like I said, the situation that the board is in, it's an open-ended situation. Like it's I usually do not like such because uh, it's too open-ended and it can literally be anything, literally. So
All the power is coming from.
no, the way it's this particular behavior.
Yeah.
So when the fan starts and then stops and then start again, obviously it's not going to pose, but the cause of that is very open-ended. So let's start from the SMC. Flow SMC just a little bit. Okay, first we reflow the SMC just a little bit. Not one word, eh? Not one word, eh? Abraham, I hope you know that it's not one word, not reset, not one word, reset. Now, so that you don't go type one word, reset now. You understand? Yeah, but I'm just saying so that stop. I just feel like you just.
Right now, I'm telling you, he's telling me please. I didn't even say that. He's talking about please. I didn't even say.
I sometimes wonder the clients that you have. I thought that they said that machine was urgent.
Yeah, but he said I will come when I'm done. I think they're busy today.
He said he's gonna come when he's done,
Yeah,
but he's the same person who said it was urgent.
yeah. It's
Okay.
KP is one who brings information.
Was it Gabi, the same person you spoke to?
Yeah.
Okay. I don't like the situation of the boat that is in. Like I said, now let's see if fancy paints and stuffs. Nah,
So
nah, I don't like this. So it's this is too open ended. That's why I didn't like it. Too open ended. Like it can literally be anything. Before we go back to the SMC, let's just check the bias. That's why I don't like this situation because it's just too open. Sorry, you cannot. It's not. It's not. And usually, sometimes you just be like, I mean, you didn't have a working mode. Now you have a working mode, and then it goes into another funny state. Okay, let's get another. Okay. So this is obviously for testing purposes. Even if it does work, you cannot leave the because this has the MA region is important. So for that, you just cannot have. Say if you were to transfer this and then it just works, you can't leave it there because I mean your board is just gonna put halfway. Uh, so we just using this to confirm that just to see if we get a different reaction on the board, not like a permanent installation. So just see uh, see what we have now on the device. Says, hmm this bias. Okay, it could also be because of the. Just give it a little bit of time to cool off.
Yes, I remember, but like my phone, I can't hear when on video call. I remember the issue was the audio I see wasn't something about iCloud. I said I can't do iCloud, but I remember you brought something which an iPhone 7 with an audio I see. Yeah, I remember that. Because I see or network issue. I think between both network issue and code I see. So if you can leave it there, I can take it, then I can see if we can do it. Yeah, then leave it by then I'll fetch it tomorrow.
Calling
Yeah, I
later.
remember. I can fetch it tomorrow, yes. I remember.
I saw that.
So you can leave it by then, I'll fetch it
Okay,
tomorrow.
this bias chip is good. Okay, let's see if it's just gonna give us the same reaction.
What? No, I have to
Okay,
see which one
so it's not the bias chip.
the
We're just
network
gonna
or
confirm
audio
that
IP. Then I'll let you
again
know.
before we take out the bias chip.
So he has to
We do
wait.
that.
He must wait before he pays. Then I'll let you know which one is it, the network or the audio IC. Okay, sure.
Okay, so it's definitely not the pliers. Stick it out. Just put this back. Also, this has orientation. You have to be aware of that when installing it.
Uh, yes. Okay, if I get it, it will take almost like a day. If I take it in the morning, at the end of the day, it will be done. I can't remember what price did I give you because it's very long time. No, I won't be. I'll be in town, but I'll just come there to fetch the device. Then I'll come and
Okay, so what we want to do is we want to let's just confirm that we're in the same
fix it. Okay, cool,
state.
no problem. Not an issue.
And then the next thing we want to do is we want to replace that SMC, and that's going to be the next thing we do before. Let's just see. Okay, just give it a bit of time to cool off. Just give it a bit of time. No, it's kind of wait for it, wait for it, wait for it. Let's give it a bit of time. Seem to save this. Very what? Otherwise, you can just remove and replace it again. Redo the parts. Okay, let's just redo the parts real quick. Okay. Let's remove the XX. Give it a bit of time to cool off, and then we can test it just to see that we're in the same state. And yeah, and then we have to put in another SMC, which is this one. Wait for it to cool off so long, and then we can prepare this SMC for the time being. First, we remove the edge bonding. So if after we replace the SMC and then the board still behave the same way, we'll have to put it aside and do something else because it's going to take us a really long time. There's so much, like I said, pretty much when you have a board that behaves that way, you pretty much it's kind of like an open-ended type of issue, and it can be anything pretty much. So okay, that is out. Let's put that aside. Let's test our board at least to confirm that the SPI RAM chip, which is the BIOS, it's pretty much well in place. uh, what's with the misbehavior now? Hmm. Okay, okay, let's just confirm that again. Okay, yeah, this is just want to be sure that we're in the same state so that, okay, that's fine. Now let's take out the SMC.
Yeah, yeah. Yeah, like, I just looked to the very icon, you know,
Okay, SMC out of the way. Let's mm, okay. As you know, SMC has an orientation. Pin 1 is going to be to the dot there. That's going to symbolize this pin 1. I'll just show you guys there. So the red pin there, one in red, that's going to be pin 1. So which is this pin 1. So oriented has to be. So it's going to be oriented in that manner. Mm, okay. Since it's in place, we just wait for it to cool off, and then this is yeah. So um, pretty much, and I mean, what do you expect? It's a board that has been to several hands, and I have no idea what was the previous repair. Yeah, even though we did fix the evident one that we saw, and then the board had to go into power but no post mode. Yeah, so just give it a bit of time to cool off. Yeah, like I said, so if this doesn't solve the issue, we'll have to move into another repair because it's gonna waste our time. Yeah, we just hope it works. Um, while we're waiting for the board to cool off, we also do further visual inspection on the board. The the backlight IC looks funny. It looks like it was slammed in place. Let's just check a bit of the outputs and see. Why do you have to flip it? Let's see. Okay, what is that and why does it have to be? Okay, yeah, that's ground. Uh, okay, I may have to lift the backlight chip because it looks slammed in place. One thing I know with the MacBook, with the backlight chip not properly installed, it's you get a beeping sound, and then your board obviously won't start. But let's test it first, and then before we even check the fan behavior, let's see how SMC works. So I like to know if my SMC works before first. I mean, so before we even continue from where we were, let's see if we didn't retrogress 16, PPDV3, it's fine, PB was. Okay, SMC did work. Okay, fine. Now we can put that back. Because if SMC didn't work, we wouldn't even worry about trying to repair. I mean, trying to make progress. We actually going back. So now let's see if our fan is going to behave differently. Oh, okay, fine. Let's quickly just remove the backlight chip because it looks slammed in place. Let's see. Mm, and that's out. Let's see what we have. Ah, feel so bad. Because now it's gonna take like a whole lot of you know minute check-ins to see what's happening. Nah, it's yeah. So what we have to do is we need to put this aside and then come back to it. So we were gonna use this board for the one of the PC8 board. Uh, yeah. So pretty much now we. Okay, so guys, we'll have to come back to this board because there's so much that we need to. I mean, if all of that has failed, so the next thing we need to do is we need to uh, fine tune it, go over. One of the reasons why I don't like such failures is, like I said, it's open ended. It can pretty much be anything. Okay, so that let's just put the board aside, guys, and then I will see you guys in the next video. Please, you have to come back to this.